Hey there. I'm going to demonstrate Faraday's law of electromagnetic induction. I have here a magnet, relatively powerful magnet. If you don't believe me, you can see that that is a magnet. I have a coil of wire right here, and I've connected this coil of wire to an ammeter. This ammeter is an analog ammeter, which is very sensitive. You'll notice that the units on there are microamperes, so it'll measure very small currents, and it's got both positive and negative currents, and so it'll indicate not only that there's a current, but also the direction of the current. And so what I'm going to do is I'm going to take the magnet, and I'm going to move it in to the space between the coils. And you can see as it moves in that the needle on the ammeter is deflected slightly to the right. If I move it out, you see that it's deflected slightly in the other direction. So what the magnet is doing is it's creating a current in the solenoid, but it's only doing it as it moves. So notice as I move it in, there's current, but when it stops, there's no current. As it comes out, I get current in the opposite direction, but again, when there's no movement, there's no current. When I move it quickly, I get a big current. When I move it slowly, I get a small current. And so that should make sense if you think about current as being a form of energy. The magnet can only give the coil of wire energy when it itself has energy. So if the magnet is still, it's got no energy to give. As it's moving, since it has energy, it can generate a current, allowing the charges inside the wires to gain energy. So the rule that we're going to focus on and try to understand is how this thing can generate a current, and then how do we know how big the current is.